Hello, Ken Weller with New Tech Inventors. About a week ago I posted a video on prototyping, and what we were prototyping was this device here, which was going to be an exhaust fan for soldering and also a fresh air, filtered air fan for painting and drying glue and paint. Okay, since then a couple of things have happened. I have produced my final prototype and my first production model. This is the model that I plan to go into production with at this point. Now, what is different from the one that you might have seen a week ago is that we've made several changes. One of the major changes was the one that we had a week ago. We were purchasing this filter, and it was an intake filter for an air compressor. And then we took this part off and we took the foam out. We cut the foam in half, making two pieces of foam, and then we would put one piece of foam back inside there. Then we 3D printed this spacer with these chambers in it. We would put that in. Then we would take our activated charcoal and fill in those chambers and put the final piece of foam back on and put the thing back together, and that was our charcoal activated filter. And that's what we have on this one right here. However, if you notice, it actually goes down to this small, approximately 1/2 inch intake. So when we taper this down, we are losing a lot of our airflow, with this being the intake side. So I think I mentioned in the last video that I was going to figure out a way to make my own filter, and I did. And on this final model you can see that instead of tapering down to go to the filter, I'm actually widening the opening, which allows for a lot more airflow. You can also notice that in the bottom of this filter there are very few holes, but in the filter I've made there are a lot more holes to allow a lot more airflow. When I made this filter, I still use the foam sheets, 2 foam sheets, a spacer, and then another foam sheet. And then this goes into a housing. It's like this one right here that opens up, and then this piece is printed and goes in just as a retainer to retain the foam, the sheet of foam, when you put your filter together. And then there are 2 little knobs on the edge of this, and there are 2 little inserts inside of here. So when these pieces go together, they'll twist until they lock in place, and then that keeps it from coming loose, and that takes a little bit of force to snap it loose if you're going to change the charcoal out. So that's the difference that I made in the filter. Now on the table here in front of you are all the parts that go into making this. There are 31 parts that go into making this helping hand attachment, and I'll go over those parts. First of all, your intake. This is the intake piece. You can see we're coming in at 40 millimeters for the fan, but we have a much larger opening at the end with this oval to go over your soldering area and collect the fumes. Then that bolts in to this main housing with the motor. So the motor is actually goes into this housing, and then bolts together. So you have your motor and your housing right here. Then on the other side, you have this gasket that just covers up some access holes. And then your filter goes on that. First, this shroud for it, and then this retainer that goes in that, and then your filter itself with a piece of foam, and the spacer for the charcoal. Then the activated charcoal goes in there, then this final piece, and then it snaps on. So that's that part of it. Then there are 4 screws and 4 nuts over here that hold all of this together. Okay, now as far as your flex arm here, we take this piece and cover it to reinforce it and make it stronger with this corrugated tubing. Then we run this wire through that, and at this end we run it through corrugated tubing like you see here out to this connector, and we use this piece of heat shrink to heat shrink that connector to the corrugated tubing after the solder connection's been made. Then we take some of this hot glue and hot glue in here to hold that end and keep it from pulling loose and putting tension on the wire. So that pretty much takes care of this portion of it. Now when the wires get together, in this housing you have 2 LEDs that go in here, and they come into the chamber, the wires from them. And then when the motor goes in, the wire from the motor goes into that chamber. And then when you fish this wire through from the power connector, it comes in here. Then you have this small switch and a cover plate that I think we showed in the previous video of how that mounts. And then this switch goes in and is wired up and then fits in place. So those are basically the 31 pieces of this final product. And the assembly involves a little bit of nuts and bolts and some soldering of this connector and soldering of the switch and stuff in this location here. Now, this can be taken loose, and these 2 pieces can be reversed. And you can actually put the filter over here and have this thing blowing out air instead of drawing air in and filtering it. It's going to be drawing filtered air in and blowing it out the other side here. So you could position this over the work area where you're painting or doing some gluing or something, and it can help dry the paint or the glue. So it can work 2 ways. It can be a blower, or it can be a vacuum for exhausting the fumes from soldering. And just to give you a brief quick look here, I did look into making one that would be portable, non-dependent on the helping hand, and this is what I've come up with, which is the same configuration and everything, except it has a mount and an adapter on the end of the plug so that you can connect a power source directly into this. But this can be used to solder, and you have these LED lights here that light up this area, that help to light the work area. This could be sold as a completely standalone unit where you just purchase this portion with the stand and with the transformer, and it's completely operational, ready to go to work like that. Or you can just purchase this part alone, and then you plug this into a power port on your helping hand and you get your power that way. You still have the LED lights in here lighting this work area, onboard filter, and so forth. So that's a little update on where we're at with that project. I'm also going to be doing a little testing. We'll show you some of the testing we do. Okay, I just noticed I brought this part up here, and I brought it up here to remind me to mention something. This was supposed to be this part here, but as you can see, it only partially completed, and the reason for that was I had a power failure. At the time I had the power failure, the power was off for about 30 minutes. So when the power came back on, the resume print was ready to go. However, the bed had cooled and I had lost adhesion, and even though the bed reheated, I never did regain adhesion, so the part was unable to continue printing. So even if you have a printer with resume print, you're limited to how it's going to work for you under certain circumstances. If the power failure is brief, I'm talking about less than a minute, off maybe for 10 or 15 seconds, then the bed doesn't have time to cool down enough, especially on glass beds, to lose adhesion. However, if the power's off for a longer period of time, you're going to lose adhesion, and even though you have resume print, more than likely you're not going to be successful. The part's probably going to break loose as you continue printing. So I thought I'd mention that since I had a good example here of where that happened. But I just thought I'd mention that. If someone out there has a resume printer, that doesn't always work. You have to be right on top of it when that power goes off to get it going again. You don't want to let it sit there in pause for a long time either, because then it's going to heat up your nozzle and start building up some residue in your nozzle. So I thought I'd mention that. The whole filter assembly consists of 4 3D printed parts. The intake, this retainer that goes inside there, then the housing for the filter itself, then we have these foam filters. One goes in, then your spacer, and that's where the activated charcoal is poured in to those chambers. Then a final filter, foam filter, is put on. Now I 3D printed the 4 plastic parts. I purchased the activated charcoal, but I had to make these. So what I did, I ended up buying some of this 1/2-inch foam, and I went out and I got a cookie cutter, and I actually took a grinder and went around and sharpened the edge of it. And now all I have to do is take it and make a filter. It's just as easy as that. So, as you can see, some 1/2-inch foam and cookie cutter sharpened up, and they're my little foam filters. So that's how I solved that problem. So until the next time, happy printing from New Tech Inventors.